Okay, today's lesson is on rate of change using graphs. So let's get started. When we look at a graph, we first want to look at the categories and the title. So the category here on the x-axis is pages printed, and it looks like it's scaled by 1,000, like 1,000, 2,000, 3,000. But you'll notice that 1,000 is over here on this mark, and we've got a mark to the left of it. And if we have starting at 0 and we go to 1,000, well, the mark in between is going to be halfway. So this would be 500. So these x-axis is actually scaled by 500s. When you go up the y-axis, it is the cost in dollars is the category, and it looks like it is scaled by 50s. So $50 for every line. So let's answer some questions and get going on the rate of change. It says list two sets of coordinates from the table. Fortunately, they give us the two sets of coordinates here. We don't have to figure it out. But what do these coordinates mean? Well, the x value here is 1,000. So what it means is 1,000 pages printed for $310, because that's in the y. In the x value here, 3,500. So 3,500 pages printed, and 460 is in the y, so for $460. So the next thing we want to do is figure out the rate of change for the cost per page printed. Well, we know that rate of change is just another way to figure out the slope of a line. So we take these numbers and we plug them into the slope formula, which is m equals y minus y over x minus x. And 460 minus 310 would be 150. 3,500 minus 1,000 is 2,500. And then we can't divide this out, but we can reduce it. So we want to figure out the biggest number that goes into 150 and 2,500. If you haven't figured it out already, pause the computer and do that. And now I'm going to tell you, it's 50. So 50 goes into 150 3 times. 50 goes into 2,500 50 times. So it is $3, that's my y value, per 50 pages printed. Okay, let's look at another example. Similarly, another single line. This one has a negative slope though, so when we figure it out, it's going to have a negative rate of change because it's a negatively sloped line. And if you know that in the beginning, that might help you out in the end. Let's look at our categories. We are scaled by ones on the x-axis, and it's time in hours. We are scaled by 50s on the y-axis, and that's distance in miles. So at 0 hours of our trip, we are 250 miles away. At 5 hours of our trip, we are 0 miles away. And that's what that is saying. And it says list 4 sets of coordinates from the table. It looks like this point goes through. So again, 250 miles away from home after 1 hour of our trip. After 2 hours of our trip, we are 150 miles away from home. So all those would be sets of coordinates. At 3 hours of our trip, we're 100 miles away from home. At 4 hours of our trip, we're 50 miles away from home. And you want to make sure that these all go through the corners. If they do, they'll continue to do it for each one. So it says, what's the rate of change? Well, we have 6 sets of coordinates. We only need 2 of them. I'm going to select this point because it has a 0 in the x value, and the last point because it has a 0 in the y value, and it makes it easy for my subtraction. So I want to go y minus y. I always do 250 minus 0, bigger number minus smaller. But then I have to go 0 minus 5. And that gets me 250 over negative 5. Well, the cool thing about this negative 5 is that I can move the negative sign anywhere I want. And for me, I'm going to move it here because what this is saying, after we simplify, because 5 goes into both of these, 5 goes into 250 50 times. What that says is we are negative 50 miles of our trip every 1 hour, meaning we are 50 miles closer to home every hour that we travel. Okay, and that shows in this negative slope. So when you have a negative slope, you have to have a negative in your rate of change over here. Let's look at the third one. This one's a little bit different because now we have 2 lines that we are probably going to compare. On our x-axis, it's ounces, amount in per ounce. And it's calories. And it's calories over here on our y, and they are scaled by 50s. So it says list 4 sets of coordinates for butter. So I'm only looking at the butter line right now. So we have 0, 0. I don't see a dot there, but I do see a dot here at 2, 100. I see a dot here at 4, 200. I don't see a dot here, but I do see a dot here at 6, 300. So I'm going to do those. You can also ascertain that there is one here at 1 and 50, 3, 150, and 5 and 250. And again, when you're asking the rate of change, you just need to select 2 of these. So I'm going to pick 0, 0, and I'm going to pick 2, 100. Plug them into the slope formula, figure this out, and then I'm going to simplify as much as I can and get it down to 50 calories per every 1 ounce in butter. When we look to the next one, cream cheese. So along the same way, we have 0, 0, we have 2, 50, we have 4, 100, and it looks like we got 6, 150. Those are our 4. What's the rate of change for the cream cheese? I'm going to pick 2 of them. So 50 minus 0 over 2 minus 0. And that would simplify down to 225 calories per 1 ounce. So if you compare both, it appears as though cream cheese has less calories per ounce than butter does, which is a little bit surprising to me. So a couple of questions. How many more calories are in butter at 2 ounces? Well, we'd go over to 2 ounces, cream cheese, butter, and we would subtract. 100 minus 50 gives you 50. We could do the same thing for cream cheese at 4 ounces. Why don't you pause your computer, figure this one out. Let's see if you got it right. And then the last one, let's figure it out for at 5 ounces. And there you go, 125 calories. So to wrap it all up, hints to understanding rate of change given graphs. You want to identify categories and scale of the x and y axis. You want to determine at least 2 pairs of coordinates. You want to plug the 2 pairs of coordinates into the slope formula. And then you want to simplify and attach the categories of the x and y axis. If you have any questions, please go back and watch this again. I went through it kind of quick, but I think you've seen these before. If you have any questions, you can also reach out to me or go and find another video on rate of change from tables. Have a good day, take care, and I hope you understand it. If you need to watch it more than once, I strongly recommend it.